In this video, we will study about inter-process communication. You might have heard about this inter-process communication in operating system as well. In OS, we talk about two processes communicating each other. When two processes are communicating each other, we call it as inter-process communication, because in a single system there might be multiple processes. Let us say there are two processes P1 and P2. If they are talking to each other, if they are writing, requesting and response, if they are talking to each other, then we call it as inter-process communication. The same concept of operating system is being adopted here in distributed systems as well, but instead of processes, here we call them as services, right. So, there are two services, services A, service B, right. There are two services A and B. So, these two services A and B, assumption in operating system is that the processes are in a single system. Okay, they have a single shared memory, like in a single CPU or a single system, both the process talk to each other in operating system. Whereas in distributed computing, we have different services. In place of processes, we have multiple services. These two services can be in a single machine or could be in different machines also. When we say distributed systems, it is obvious that we have lot of computers connected together. So, it is less chances that services are in a single system. So, in system 1 we have service S1, in another system we have service S2, or in another system we have S3 and so on. So, distributed systems are a collection of computers, right. So, each computer has one service. So, the communication between the services of different computers is referred to as inter-process communication here, right. It is same as the communication between the processes in operating system. We use the same terminology, inter-process communication, to express the communication mechanism between different services of different computers in a group of computers, which we call them as distributed systems, right. So, we already know they are composed of collection of concurrent processes interacting with each other by means of network connection. So, here they are connected through network, systems are connected through the network and they are communicating with each other, right. So, IPC is the fundamental thing using which we are telling them as that no, systems are looking like a single system, right. If this communication is not there, we cannot say that they are looking like a single system, right. So, IPC is the one what ties together the different components of a distributed system, thus making them act as a single system, right. That is why IPC is a fundamental aspect of distributed system design and implementation, right. So, why do we use IPC? IPC used to exchange data and information and coordinate the activity of processes, right. So, IPC is a mechanism for communication between different services, or in operating system different processes. Idea is the same what we talk about that, right. So, types of inter-process communication in distributed systems. In operating system, we have two types generally. One is message passing, the other is shared memory, right. In operating system, we have two types of inter-process communication, message passing and shared memory, whereas in distributed systems, we have three different types of IPC. What is that? First one is message passing. It is same as that in operating system, right. So, message passing involves processes communicating by sending and receiving messages. So, though I am using processes here, the term processes here, I mean to say I am also referring to services, right. So, message passing involves processes communicating by sending and receiving messages. Messages can be structured data packets containing information or commands, right. So, the structure and the content of a message may vary according to the model, right. So, simple example to understand message passing is, I send you a WhatsApp message, you read it and reply. We do not control each other, only exchange messages. I am not controlling your message, I am not having any command or control over your WhatsApp that you should read only these messages, you should not read these messages. There is no such control. I am sending message, you are receiving, you are reading and replying, that is it. We do not have control over each other. It is our individual to read the message and reply or not. That is message passing mechanism. The second one is the most important one, remote procedure calls, RPC. Very popular IPC mechanism in distributed systems. Yet today it has lot of value in industry when people work with talk about communication between different systems, right. So RPC, remote procedure calls, right. So RPC allows one process to invoke a procedure in another process, typically located on a different machine over a network. What happens here? So I am in one system, there is another system, right. So from this service S1, from this process P1, let's say I am calling a function, I am invoking a function available in S2. There is another service S2, it contains some procedure that I am invoking it from S1. From S1 I am calling that service in S2, right. So it abstracts the communication between processes by making it appear as if a local procedure is being made. It's simple as that function calling. I know you might have studied about function F1, there is another function F2. From F1 you are calling F2, right. So same way, but this F1, F2 functions are not in a single machine, they are in different machines. That is the point here in distributed systems, right. So RPC framework handles details like parameter marshalling, network communication and error handling. It's simple as that. Call a function that runs on another computer as if it's local. Simply you can call another function. Another simple layman example, you call a restaurant and say please prepare one pizza. You don't care who cooks it, how it is cooked, you just get the pizza. You are just calling and saying I want pizza and you get the pizza. You are least worried about who is preparing it and how it is being made, right. So it's function when we call services, right. In one system there is one service, another system there is another S2 is there. You are calling service S1, you are invoking service S2 from S1 as if assuming both are local to each other, right. That is remote procedure call. And the third one is distributed objects. Okay, so we have heard about object oriented programming, and objects play the whole game, right. Communication happens only through objects. It means in C++ or OOPS concept terms, I have class C1, it has an object O1. I have another class C2, object O2. You might have studied a lot about objects C1, object O1 calling some methods in C2, right. So using objects we are calling the functions, we are communicating with each other. So that is the idea behind distributed objects. This is the implementation of the RPC model for the object oriented paradigm and contextualizes this feature for a remote invocation of methods exposed by objects. So only through objects we call the functions. Each process registers a set of interfaces that are accessible remotely, right. So simple example to understand this, use remote objects as if they exist in your program. Okay, a remote layman example here, a remote TV with a remote control. TV is in another room. You can turn on, off, change the channel, increase volume. You can do everything with that remote. So remote is your object here, and there is a function called there are so many methods, right. TV is an object here, and you have lot of methods, data methods, increase volume, all these are different methods in that particular OOPS concept, right. So distributed objects primarily says that we invoke the methods in another function or in another class through the objects. So basically object oriented concept mechanism we use it here. So IPC mechanism, if the distributed systems are based on OOPS concept, then we have to use distributed objects concept, right. So these are three different types of inter-process communication mechanisms we have in distributed systems. Then models for message based communication. So the most important one is message based communication. In that we have different types. The first one is point to point message model. Okay, this model organizes the communication among single components. Point to point means only directly one to one. Each message is sent from one component to another, and there is a direct addressing to identify the message receiver. So fixed thing, in WhatsApp I send message to you only, your name, I search for your number or name and I send it to you. It comes only to you, right. That is point to point. In point to point communication model, it is necessary to know the location of or how to address another component in the system. Only if I know your number, I can send message, one to one message, or otherwise it could be broadcasting only. So in point to point message model, communication happens between only two different entities. and it is important to know the destination or the other component's address. The second one is publish subscribe message model, publishing and subscribing message model, right. So there are two roles, publisher and subscriber. It's very simple. The publisher provides facilities for the subscriber to register its interest in a specific topic or event. So the publisher always keeps sending the messages. It's like your WhatsApp channels. You see, there are a lot of publishers, there are a lot of WhatsApp channels. If you subscribe, you keep seeing their messages. Whatever topic of interest you are interested in, you will follow that particular channel. Then you will receive message only with respect to that channel. It is that model. However, there are two major strategies for dispatching the event to the subscribers. How do I send messages to the subscribers? The publisher is creating a WhatsApp channel. He is sending messages. But how is that, how we are receiving the messages? How are we receiving the messages, right? So there are two strategies. Push strategy. In this case, it is the responsibility of the publisher to notify all the subscribers. Pull strategy, in this case, publisher simply makes available the messages, and it is responsibility of the subscriber to check whether there are messages or not. Push and pull strategy, right? So when they are sending messages, if the publisher is sending messages, sometimes he will just send the message and notify also. Whereas in pull strategy, he will just put the message. It is our responsibility to keep checking frequently whether the message is available or not, right. So second one, publish and subscribe message model, and the third one is request reply message model. Okay, so the request reply message model identifies all communication models in which for each message sent by a process there is a reply. Like in client server, you request and you definitely get a reply. This model is quite popular and provides a different classification that does not focus on the number of components involved in the communication, but rather on how the dynamic of the interaction evolves, right. So this is a request reply model. So for every request there will be a response. That's what this model says. So these are different kinds of models for message based communication, right. So in summary, what we have seen, we understood what is IPC. There are three types of mechanism in distributed systems: message passing, RPC, remote procedure calls, and distributed objects. And in message based communication, there are three different types of models. One is point to point model, publish subscribe model, and the third one is request reply model. So this is about the inter process communication which happens in distributed systems.